going to be starting with Module 4, Ratios and Proportion. Let's start with understanding what a ratio is. A ratio is a comparison of two quantities using division. You represent a ratio either in a fraction form or in the form x is to y. This means that x is in ratio to y. This means you read it out as x is to y. The second thing we're going to understand is what a proportion is. Proportion is basically stating that two ratios are equivalent. So when I say x by y, which is a ratio, is to a by b, this means that these two ratios are equal. The whole term, the whole thing is called proportion. So when you expand it, you write it as x is to y is in proportion to a is to b. This is a normal way of solving it or understanding how they are equal is by using this formula called product of means and product of extremes. So you equate the product of means and equate it to the product of extremes. So when I say product of means, these are the means, the middle terms are called the means, and the extremes are obviously x and b. So when I say product of means is y into a is equal to product of extremes, x into b. This is how proportion is represented. The next thing we're going to understand is certain terms. Now, if I say b is equal to c, if the means are equal, that means the first one is called the first proportion, the two equal means are called the mean proportion, and the last extreme one is called the third proportion. These are the terms you use. So, if the means are equal, A is the first proportion, B and C are the mean proportion, and D is the third proportion. In this, if y is equal to A, these two will be the mean proportion, x is the first and b is the third. If b and c are different terms, that means if they are not equal, you write it as A is the first proportion, B is the second, C is the third, and D is the fourth. Same way, x, if y and A are not equal, x is 1, y is second proportion, A is third proportion, and B is fourth proportion. These are the basics of ratio and proportion. We're going to understand a few other terms before starting to solve ratio and proportions. The first term is called a duplicate. A duplicate of any term is a square of that term. So if x is that term, if I ask you to find the duplicate of it, you square it. Triplicate, if I ask you to find the triplicate of a term, you cube the term. So x, the triplicate of it will be x cubed. So this is a triplicate. Now if I ask you what a subduplicate is, if x is a term, root of that will be the subduplicate. And subtriplicate, if x is the term, subtriplicate of that term will be cube root of x. This is square root of x, this is cube root of x. And cube root of x will be the subtriplicate of x. We're going to start solving the sums. And 1, 2, 3, 6, 7, 8 and 18 are the sums we're going to solve. We're going to start solving the sums. The first sum, we're going to look at the A part of it. It says 25 to 75. If I have to find the ratio of this, the direct thing to do will be to convert it into a fraction form. When you do 25 divided by 75, I can directly cancel it. The form of a ratio should be always expressed in its most simplest form. That means I have to keep dividing it or cancelling out common terms in order to get the simplest form of it. So 25 ones are 25 threes are, you get it as 1 by 3. When I have to represent the form of a ratio, I always have to write it as 1 is to 3. Moving on to the second part of it, when I solve B, it says 30 centimeters to 2 meters. When I solve this, you have to always realize that when you're converting anything into a ratio, it has to be of the common term. If you notice, this is in centimeters and this is in meters. The first thing you should do is to convert either of the following into the same form. So now, if either I convert centimeters into meters or I convert meters into centimeters. 1 meter is equal to 100 centimeter. So therefore, 2 meters would be equal to 200 centimeters. Okay? So then when I change it, it will become 30 centimeter to 200 centimeter. So when I take it in the form of a fraction, I cancel the zeros. If you notice, you cannot cancel it further than 3 by 20 because 20 cannot be divided by 3, and hence the ratio will be 3:20. The next sum we're going to be solving is the third sum, third part of it. This says rupees 7 to 75 paise. Now, the next thing we need to do, again, this is in different denominators, as in you have to convert either rupees to paisa or paisa to rupees. 1 rupee is equal to 100 paisa. Therefore, 7 rupees will be equal to 700 paisa. Next thing to do is it will be 700 paisa to 75 paisa. Next, I convert it into a fraction form. So when I do 700 divided by 75, I need to convert it in the most simplest form. So 25 threes are, 25 28s are. Therefore, the ratio will be 28:3. We're going to be moving on to this fourth part. Fourth part says 1 hour to 22 minutes. Again, 1 hour is equal to 60 minutes. Therefore, I can write directly this as 60 minutes is to 22 minutes. When I convert it, it will be 60 divided by 22. Okay? 2 11s are, 2 30s are. Therefore, the ratio is 30:11. We're going to solve the second sum now. It says find the duplicate and triplicate of 2:5. So if the ratio is 2:5, the duplicate is the square of the term that we need to find. So the square of 2 is 4 and the square of 5 is 25. So it's a very simple problem. You directly just write the answer as 4:25. Triplicate in this sense will be the cube of the terms. So directly 2 cube is 8 and 5 cube is 125. This is the answer to the second problem. Moving on to the third problem, they're asking you to find the subduplicate of 9:625 and subtriplicate of ratio 27:125. So if I ask you to find the subduplicate of 9:625, I just need to square root it. When I square root both the terms, you know square root of 9 is 3 and square root of 625 is 25. So the direct subduplicate of the term that they've given of the ratio 9:625 is 3:25. Same way, if they ask you to find subtriplicate of 27:125, I need to cube root it, and cube root of 27 is 3 and cube root of 125 is 5. Therefore, subtriplicate of the ratio 27:125 is 3:5. These are the 4 types of things that we have learnt. We're going to be moving on to the sixth question. The sixth question, they're asking you to find the fourth proportion of 2, 5 and 6. Now that means, obviously to find the fourth proportion, that means B is not equal to C. That means the mean terms are not equal. Therefore, I assume the fourth proportion to be X because they're asking you to find it. The next thing to do, that means the 4 proportions are 2, 5, 6 and X. 2 being the first proportion, 5 being the second, 6 being the third and X being the fourth proportion. Now the way to represent it will be 2:5 is in proportion to 6:X. Now what do I need to do next is by finding the product of the means and equating to the product of the extremes. The next thing to do will be product of means is 5 into 6 and product of extremes is 2 into X. 30 is equal to 2x. Therefore, x is equal to 15. Therefore, the fourth proportion is equal to 15 is how you end the answer. Moving on to the seventh question, they're asking you to find the third proportion of 10 and 20. If they ask you to find the third proportion, they've given you only two terms. It is directly assumed that you're doing the rule B is equal to C. That means that the mean terms are equal. When the mean terms are equal, there are only three technical numbers that are involved. So what you do is, you assume the third proportion to be x because they're asking you to find that. That means out of 10, 20 and x is how you represent it, because they've given 10 and 20. You can assume either one of it to be the mean term, but since 20 is succeeding 10, you assume 20 to be the mean term that are equal. So this is A, this is B, this is C, and this is D. That means this is the first proportion, B and C are the mean proportions, and x is the third proportion. So when I represent the form of a proportion, it will be 10 is to 20 is in proportion to 20 is to x. So again, I apply product of means equal to product of extremes. Product of means is equal to 20 into 20. And product of extremes is 10 into x. So I do 400 divided by 10 is equal to x. Therefore, the third proportion is 40. This is how you find the third proportion. We're going to move on to the eighth question. The eighth question asks us to find the mean proportion between 4 and 16. When it says mean proportion, we have to directly assume it to be of the second type. That means B is equal to C. That means the mean proportions are equal, and hence first and the third are given. Basically, they're saying that this is the first proportion and this is the third proportion. So I assume the mean proportion to be x. So when I represent in the form of a proportion, it will be 4 is to x is in proportion to x is to 16. So when I do product of means and product of extremes, I take product of x and x. So x into x is equal to 4 into 16. So x into x is x square is equal to 64. Therefore, mean proportion is 8, because root of 64 is plus or minus 8. And since in ratio we don't take negative signs at the moment, we directly assume it to be x. So therefore, when I write it in the form of this thing, x is to x. So it will be 4 is to 8 is in proportion to 8 is to 16. We're going to do the last sum under ratio proportion. This is the 18th sum. They've given you A is to B is equal to 1 is to 4, B is to C is equal to 2 is to 5, and C is to D is equal to 3 is to 7. They've asked you to find A is to D. The only way of doing that is to equate B and B and C and C, because it's common amongst three ratios. So the first step you do is to take any two ratios. So let's start with A is to B is equal to 1 is to 4, and B is to C is equal to 2 is to 5. Now the first step is to equate B and B. How you do that is to find a common ground. Now 2 and 4, if I multiply this whole thing by 2, B over here will also become 4, and hence it will become equal. So what I do is, next step would be, if I multiply it, A is to B will be equal to 1 is to 4, it will remain as it is, and B is to C will become 2 into 2, 4, and 2 into 5, 10. So now the new ratio for B is to C is 4 is to 10 and not 2 is to 5. The next step you do is to equate 4 is to 10 to 3 is to 7. So when I take B is to C as 4 is to 10 and C is to D as 3 is to 7. The first rule again, as I said before, is to equate C. How you equate C is by comparing 3 and 10. I can multiply this into 3 and this into 10, because there is no other common denominator or no other common factor. When I do this, the whole of B is to C will become 3 into 4, 12, 10 into 3, 30. When I convert C into D by multiplying the whole thing into 10, C is to D will become 3 into 10, 30, and 7 into 10, 70. Now that C are equal, you can notice that B over here and B over here are different again. Because now, if I write all three together, I'll write A is to B is equal to 1 is to 4, B is to C is equal to 12 is to 30, and C is to D is equal to 30 is to 70. The goal is to equate B's and the C's because they're common. If you notice, the C's are equal because they are 30 and 30, but the B's are not equal because this is 12 and this is 4. So you need to work backwards this time because you've already changed the B. Now, the only way I can convert the 4 into 12 is by multiplying A is to B by 3. So A is to B will therefore become 1 into 3, 3, and 4 into 3, 12. And the remaining will be as this will remain as the same. T is to 70. You can verify the answer that you get by checking if the B's are equal. This is 12 and 12, and C's are equal because it is 30 and 30. They've asked for A is to D. Before writing what A is to D is, it's better to write what A is to B is to C is to D is. So when I write A is to B is in proportion to C is to D, you get your answer as 3 is to 12 is to 30 is to 70. So when I directly write the answer as this, it's easier to find what A is to D is. A is to D is just 3 is to 70. So your answer will be 3 is to 70.